So in the previous video we have seen how to detect a motion using PIR sensor. So I will just clear these stuffs because I don't need those now. Okay, so let's see how to detect temperature using a sensor alongside the Arduino. So basically we have to use the TMP36 sensor over here. We go to the all. So this is the temperature that we use to calculate or use to measure the environment temperature. So take that sensor out. So it also have 3 pins. Power and ground as same. The ground needs to be grounded and power needs to be connected to either digital pin or maybe default 5 voltage. Then this V out basically sensor variations of signals because the temperature has several variations. So basically it's an analog input. So analog input need to be connected to the analog input pin in the Arduino. And that's the idea. So let's take out the Arduino board. Like this. So this is the power pin. So I will connect the power pin maybe to this default 5 voltage. Then ground can be connected to this ground maybe. Then this is the V out. Basically it's a analog signal, right? So I think the wiring is not quite good, so I will pull down my sensor over here like this. Okay, so power I can connect like this, and ground I can connect like this. Then this is the analog output. So analog output will be taken to the A0 analog pin. Then go to the code. Right. Then since this is analog input, we don't need to configure its pin mode, right? So all we need to declare is our serial monitor, right? Because we need to print the output. Then we need a variable to take the read and corresponding or generate the corresponding temperature value. So read basically taken as analog read. So it's something like this. Then you can simply check whether it is working correctly or not by printing out using the serial monitor. So if I toggle this now, yeah, it's printing some sort of a meaningless stuff because I haven't declared a delay over here. So if I specify maybe 5 millisecond delay, now whenever I start simulating, okay, semicolon needs to be there. Whenever I start simulating, it will again yeah, because I print like that, this line is basically wrong, right? I'm reading the read after the read. It's completely wrong. It needs to be specified as A0 pin, right? So A0. Then start simulation. Yeah, now it's prints some sort of a default value because now the Celsius range is 25. So whenever I'm increasing it, accordingly the value also increase. Whenever I decrease it, accordingly value also decrease, right? But this is just a uh, analog value. This is not the actual temperature, right? So we need to uh, construct a sensor value which is relevant to the corresponding temperature. So basically what happened over here is it needs to be mapped to some sort of a range, uh, because these uh, Arduino analog pins are working on 0 to 233 range of values, because it's using 10-bit registers to take the analog input. So there are 2 to the power 10 analog variations, right? If you specify analog signal like this, there are total 2 to the power 10 analog variations. So that's why it represent as 0 and 123, because there are uh, this amount of numbers, and 2 to the power 10 is also equals to this number, right? So you don't need to consider those stuff if you are a beginner. All you have to consider about is how do we take a relevant value using analog pin. So analog pin, when you are using some sort of analog pin, you have to derive the corresponding voltage using this analog input. So when you are deriving something out of the input, you have to use a function which is known as transfer function. So transfer function is basically, it's something like this: y samana mx plus c, right? So these m values, c values, those will be differ uh, with the sensor that you are using, right? But when it comes to uh, this temperature sensor, all we have to do is map these values corresponding to the voltage level. So all we have to do is uh, divide this sensor value, in my case it's read, by 1024, then multiply it by 5. So I will be having corresponding voltage level, right? So we can go to the TinkerCad, then we can specify our transfer function over here. So I will use temperature, or let's say temp voltage or something like that. So temp voltage is taken from the read divided by 1024 multiplied by 5. Then I can print this temp voltage. So whenever I printing a default temp voltage, it's 0 now, I guess. Yeah, this temp voltage needs to be changed accordingly, because I am reading this value divided by 24. Yeah, maybe because since I specified as integer, it just ignore the corresponding float values. So I need to specify it as a float. Now I toggled it, then there will be corresponding it's need to be having output. So let's reload the diagram. Then let's go back to the code, start simulation. Still, yeah, because this read is divided to this value, maybe let's use double. Hmm. Look, read this. Yeah, so there is some sort of a temperature value. Let's print that one. It is printed. Okay, analog read is printing, and yeah, maybe we can use a map function if this one is not working. Basically, temp all map read from 0 to 23 to corresponding voltage levels. Then let's see whether it generates some output. Alright. Then I think this temp wall is the problem. Mm, yeah, you need to take this read as a double as well, because there is some data type convention, because whenever you uh, divide integer and multiply it by 5, it will produce some sort of a double, so there need to be some sort of a typecasting, but even without typecasting we can do the corresponding task by having a same data type. So I will specify read and temp voltage both as double. So whenever I start simulating, now I have the corresponding voltage value, right? So both are now increasing, so I don't need this one. So let's start simulate. Now it's printing corresponding voltage value. So whenever it passes some sort of a voltage threshold, maybe I can trigger some sort of a component using these digital out pins, right? So that's how we are using temperature sensing.